directly proportional to t, then what does that mean? And guys, you need to know what directly proportional means when you set up an equation, okay? So if I say, okay, for example, if I say my weight, okay, is directly proportional, okay, proportional to how much candy I eat, okay, then what that would mean is if I called my weight W and I called candy C, that means if I said W equals something C, there's some constant being multiplied to get my weight. So for example, if I ate, let's say this is in pounds, if I ate 3 pounds of candy, okay, then this thing might be like, I don't know, let's say, I don't know, a number would be like 50, okay? Let's say K was equal to 50, then that means I would weigh 150 pounds. This is actually not gonna work out exactly what I want. But like if I ate 2 pounds of candy, then look at that, I would only weigh 100 pounds. Do you see that? Okay. So when you say something is directly proportional, it just means you multiply it by some number and you get your answer. Everybody good with that? Okay. So like another example would be like my intelligence is directly proportional to I'd say like Chris's intelligence. Okay. And so that would be like, let's just talk IQ. If Chris's intelligence, so we'll put a K here. If Chris's intelligence was 100, like say his IQ was 120, okay, then I would say my intelligence, this is a true story by the way, would be 240, like that would be my IQ. Does that make sense? So if we set up a formula, then it would be like Miss Chang, I'll just call myself T because we both start with C. So T would be equal to some number times Chris's intelligence. Does that make sense? Okay, that's when we say directly proportional. We're saying there's just some number that if you multiplied that, you would get your intelligence. Okay, so up here, when they say Y is directly proportional to T, what they're saying is if I had Y here, okay, you would multiply it by some number. You'd multiply T by some number to get Y. Do you guys see what directly proportional is? Okay, and directly proportional doesn't have to be, this K doesn't have to be a big number. It can be a small number. So for example, if I were dumber than Chris, okay, this number could be like 1/2, right? The constant could be 1/2, and then my intelligence would only be 60. Does that make sense? Okay, so as long as it's just some number here, okay, then my intelligence is directly proportional to Chris. I mean, let's say, you know, Chris takes drugs and his intelligence goes down. So that would be like a 50. Well, then my intelligence would be 50 times 1/2. So my intelligence would go down too. Does that make sense? Okay. So that's what directly proportional means. It means that you multiply by some number to get the answer. Now, inversely proportional, okay, means a flip. So what it means is Y would be equal to K. It's the same thing here, but instead of T, you're inversely proportional. So what you do is you'd say times 1/T. Okay, so that would be equal to, really, that's kind of awkward. You just say K/T. Okay, but it's K times, it's still a constant, but it's times, this would be, I'd say flip. It's a reciprocal, 1/T. Okay, so that's actually the opposite, meaning that, you know, as T gets bigger and bigger and bigger, I would get smaller. Okay. All right. If Y is jointly proportional, so what jointly proportional means is actually all these things proportional. When you see the word proportional, you just put a K there. That's all it means. Okay. If it says inversely, it means you flip it. If it doesn't say anything, that means you leave it. If it says X and 5 minus X, what you say is first you put a K, then you just put X times 5 minus X. Okay, because Y is proportionate to both the X and the 5 minus X. Okay, so you just put them next to each other, and you just don't forget the K, because K is that, what we call the proportionality constant. Okay, all right, so knowing all those things, and that's just setting up the problem. We're going to go into word problems tomorrow. Okay, so this is going to prepare you for the word problems tomorrow. The rate of change of N with respect to S. Okay, what is that in calculus talk? How would I write that down on my paper in notation? The rate of change of N with respect to S. Do you see that? The rate of change of N with respect to S. That's like the rate of change of y with respect to x, basically, okay? This is dn ds is proportional, guys. What do you put down for is always in math anyway? Equals, okay? Guys, what do you put down for proportional that I just taught you? K, okay? And then it says 250 minus n. Guys, this right here is a family, 250 minus n. So when you put it down as a family, and that's what they're saying. The dn ds is equal to k times 250 minus s. And this is number 14 on your homework, so we can also just do number 14 on your homework together. Is this all of your notes? Is that all? Yeah. Okay, so this is also number 14 on your homework. I might have numbered differently, so let me know if it's not exactly number 14. Okay, you guys good with that? What we're going to do is solve this. Now, do you notice we have no initial condition? Okay, meaning they don't tell us, sometimes they say n of 1 is equal to 0 or something like that, okay? We have no initial condition, so therefore, guys, we cannot solve for Charlie. So what we're going to do here is we're going to have a plus C in this answer. Charlie won't be able to be solved. These problems are a little bit, this problem, actually, not these problems, but this problem's a little bit more challenging, and let me show you why. Hopefully you did your homework last night so that you can understand what we're doing today, because we're going to add a little bit to it. I need to solve this differential equation. I have both, see, this is like a y. I have y's on this side. Before this unit, you never had y's on this side. We only put x's on this side, okay? Putting a y on this side makes the problem a little bit more difficult because you can't just integrate both sides. But it's not really that bad. All you do is you act like an immigrant. First, you separate, okay? So first you separate. So you have an n here, okay? So what you want to do is move all the n's to the left side, all the s's to the right side, okay? So let's go ahead and separate correctly first. You guys good? I can multiply both sides by ds. You guys good with that? First you multiply both sides by ds. Okay, so this ds is gone. Then what is on this side that I need to move to the left? Okay, so how would I move that to the left? Divide both sides by 250 minus n. So I get dn over 250 minus n is equal to k ds. Are you with me so far? First you separate. Did I separate correctly? Are all the n's on the left and all the s's on the right? And did I use real algebra, not the fake stuff? Okay, I'm good. Then you what? Then you integrate. So what I'm going to do is I'm going to integrate both sides, okay? Let me just start on the right side first, because the right side is actually easier to integrate. If I have the integral of some number times dx, what is that integral? 3x. Okay, so do you see k as some number? Okay, so that just carries down. And instead of x, what am I going to put? S. Okay, so that's how I integrate the right side, but don't forget Charlie. So ks plus c. Do you guys see how to do that? Do it. The k always just pulls down because it's a number. You don't know what number it is. This doesn't matter. It's just a number, and you pull down the s. All right. Over here, okay, how do I integrate this? It's u substitution. What's my u equal to? Not just n. The whole thing, okay? Make your u the whole thing. Do you guys remember what I did when I made the whole u my bottom? Do you remember that shortcut? It's been a long time since we've done u substitution. You divide by the derivative of the bottom. Do you remember that? So then what number really is on top here though? 1. Okay, so I'm going to put 1 on top. Let me just make sure you understand. It's kind of like this dn is kind of like over here. You know how you have the integral of something with the dx? The dn is kind of here. But there actually is a 1 here, even though you don't see it. So let me just put it in. That's a 1. And then do you remember we said, then what you do is you take the derivative of the whole bottom. Guys, what's the derivative of 250 minus x? -1. This is tricky. Everyone thinks it's 1. But the derivative of 250 minus x is -1. So the derivative of 250 minus n will be what? -1. So you divide everything on top by -1. And do my x's cancel out? Yes, there are no x's, so they do. So then what you do is you take this number and you put it at the beginning. And then do you remember what you multiply by? ln of the entire bottom. And this only works if you made the entire bottom your u. And this is a minus sign, by the way. Okay, so the entire bottom is by u. I took the derivative of u. I divided by the entire top. Okay, if all my x's cancel out, then this is a shortcut to ln an ln problem, a 1 over u du problem. Okay, so this answer is negative ln of 250 minus n. And remember, I told you the absolute values you can drop in these problems, but I need a parentheses anyway, so I'm just putting the absolute value there. And this would be ks plus c. Okay. Now, what is my goal for every differential problem? First you separate, then you integrate. Sometimes you what? Exponentiate, okay? And then you solve for y and c. My goal is to solve for y and c, or not c in this case, solve for y, right? My goal is to solve for y. You guys agree? What's y in this problem? N. So my goal is to solve for n. You agree? Okay, let's pull this n out of here. The first thing I want to tell you guys is, you know, you have to exponentiate, right? You have an ln of y problem, ln of n. This positive keeps you from exponentiating. I'm just letting you know. You can take an e to the ln and the cat falls out. Okay, so that would be equal to 3. Okay, if you tree a log, the cat falls out, and if you log a tree, the cat falls out. But guys, if you tree a negative log, nothing falls out. Okay, you can't have a negative log. Okay, how can I change this negative? Yeah, you just factor out -1. So what I'm going to do is I'm going to multiply this side by -1, and I'm going to multiply this side by -1. Multiply everything by -1. On this side, you're going to get ln of 250 minus n. On this side, you're going to get negative ks plus c. Well, I know it's minus c, but minus c is just -1 times c, right? Isn't that really just another constant, right? -1 times c, e to the c, 4 divided by c. I mean, it's just another constant. So while all these change signs, the constant doesn't have to change signs. You can change it if you want, okay? But the thing about changing it is just make sure you keep it negative when you plug in, that's all. So if you want to change it to negative c, you're good. But my constants, I like to keep it as plus c. That's just me. Okay, but make sure you understand, this constant is not the same as this constant. So I'm going to change this to c1. It's not the same. Make sure you also understand, if you don't change it to c1, I'll still count it right. Okay, just make sure you understand that. But now we're working with this equation down here for the c, not this one. Don't go back to this one because these c's are not the same. Okay, because this c is actually the negative of this c. Okay, all right, we've changed everything to a positive ln. Okay, so my question is, can I exponentiate now? Yes, so let's go ahead and do it. Okay, exponentiate just means kind of like raise everything by e on both sides. As long as you do it to both sides, you're fine. Okay, on the left side, what's going to happen is the cat falls out. Okay, and also the absolute value falls out. Okay, on the right side, what I'm going to get is e to the negative ks plus c. Okay, do you guys see that that c now goes up in the air? How do I get that c to go back down? Do you remember? Okay, you put it to the front. So guys, a shortcut would be you just put it to the front. But let me tell you what's really happening there. What's really happening there is I'm breaking this up into 2. Okay, isn't e to the c times e to negative ks? Don't you, if you have the same bases and you multiply, don't you add exponents? Aren't those the same things? But what is e to the c? Isn't e a constant? Isn't c a constant? Isn't that just another constant? Okay, and that's why someone said you can just pull it to the front, and you can. It's really just multiplied by some other constant. But we're really not pulling this constant to the front. We're really pulling e to the c to the front, okay? And so technically, if you move from this step to this step, I'm not going to have a fit or anything. I'll be okay with it. But, you know, just understand that this c was not the same as this c. So technically, you should call that c another number, okay? Or whatever number we called it before. Yeah, we should call it some other number. Okay, but technically you should, but if you don't, I'm not going to have a fit over it. And there is almost my answer. Okay, remember what we said we're trying to solve for? What are we trying to solve for? N. So then just move n to the right. So n would be equal to 250 minus c e to the negative ks. Okay, all I did was add n to both sides, but then I kind of switched places because I wanted the n to be first. Okay, are you guys with me so far? And this is your answer, okay? You have to leave c because you have no initial condition, and you have to leave k, and that's because to find K, there's no way to find K either. You actually need a second condition to find K, and we don't have a second condition either. Okay? Okay, let's do calculus talk. You ready? The rate of change of R with respect to T. How do you say that in calculus talk? Okay, so write it down. dr dt. How do you do is? Equals, okay? Inversely proportional. How do you do proportional? K, okay? How do you do inversely proportional to, well, let's just do this. How do you do the square root of R? What's that? Square root of R. Okay, square root of R. What does inversely proportional mean? Okay, so you're going to multiply by 1 over square root of R. Okay, so that's your setup, guys, for problem 15. First you separate, then you integrate. I'll let you guys take care of that. Notice, guys, do you have an initial condition here? You have an initial condition? No, so you're not going to solve for C, and you're not going to solve for K. Everybody good with that? You'll have C and K in your answer. Let's look at number 16. Let's set this up. The rate of change of Y with respect to X. Do that in calculus talk. What is that in calculus talk? dy dx, okay? Varies jointly, okay? Varies jointly is the same thing as proportional. So what do I do? Equals K. It varies jointly with both my X and my L minus Y. X times quantity L minus Y. Okay, that is your setup. Okay, first you separate, then you integrate. All right. Okay, so when you separate it, we're going to move all the Y's to the left side. And I'm going to move all the X's to the right side. But you have to use real algebra, not the fake stuff. Okay. Then what you do is you integrate both sides. Okay. And you do it separately. So don't try to do it at the same time. I'm telling you, I mess up when I do it at the same time. You're going to mess up too. Okay. So what you're going to do is you're going to rewrite this. This is an integral you know how to do. Okay. And so this one, I'm actually going to just pull the negative out if you guys are okay with that. Actually, you don't have to. Okay. On the right side, let me just work the right side. The right side would be, first you add 1. Oops, I want to do that in a different color. You add 1, divide by the new exponent, which is -1, right? So this is going to be negative y to the -1 plus c, but I'm going to move all my c's to the right side. Okay, let me do this integral over here. This integral is going to be negative x squared over 2. Okay, did you guys get that far? Okay, all I did was integrate the left by itself, act like it was a problem by itself. Integrate the right side, act like it was a problem by itself. Okay, so first you separate, then you integrate. What's your third step? Sometimes you exponentiate. Do I need to exponentiate here? Do I have an ln of y? No, don't need to get rid of the ln of y. So don't need to exponentiate. An ln of x doesn't matter because we're trying to solve for y. That's why the ln of y matters. You'd exponentiate only the y. Okay, first you separate, then you integrate. Sometimes you exponentiate. Then you do what? What are your next steps? Solve for y and c. You guys tell me, what do you want to do first? Solve for y or solve for c? Okay, so let's solve for, I heard c, so let's solve for c. Okay, so let's go look at the initial condition. You can't solve for c unless you look at the initial condition. So x is equal to 1 anytime y is equal to -0.25. Do you agree with that? Okay, I'm going to change this to a fraction. This would be -1/4. Okay, so this means everywhere there's a y, I'm going to put in -1/4. So this will be -1/4, okay, raised to the -1, because exponents come before multiplication, is equal to, the x is going to be 1, so this will be -1/2 plus c. You guys with me so far? Okay, I'm going to change this negative here to just the, just the top, because it doesn't matter which one I choose. I'm just going to choose one. That way when I flip it, it won't be a big deal. You can put it on the bottom if you want, okay? All right, so if I have a fraction raised to -1, what happens to that fraction, guys? Okay, it flips over. Okay. You guys good so far? I'm going to take care of, exponents get taken care of before multiplication. So you take care of this -1 first, okay? So 4 over -1, isn't that just -4? So this will be 4 is equal to -1/2 plus c. So what's c going to be equal to? C is equal to 4.5. If I wanted a fraction, it'd be 9/2. I don't know which one's easier, so let me just write both. Okay, after I solve for c, Now I replace c in this one, so I need to be working with this formula right here. Okay, I put in the c. So the c is, I'm going to put in 9/2. So the c is 9/2. You guys with me so far? So what I have is negative 1 over y is equal to, put it in a different color, negative 1 over y is equal to negative x squared over 2 plus 9 over 2. What's my goal? Solve for y. I've already solved for c, right? So my goal is to solve for y. So I want to isolate that y. At this point, there's several things you could do. Let me multiply everything by y. How about that? I'm going to get rid of the y on the bottom. So let's multiply this side times y over 1 and this side times y. This will get rid of the y. So on my left side, I'll have negative 1. On my right side, I'll have negative x squared y over 2 plus 9y over 2. All I did was multiply everything by y. You have to distribute that, right? Okay. Give me a suggestion. How do you get rid of the 2's? Multiply everything by 2. Is everybody okay multiplying everything by 2? So if I multiply the left side by 2, I'll get negative 2. Multiply the right side by 2, I'll get negative x squared y plus 9y. Okay, guys, how do I solve for y? Can't you just pull out the y here? Right, don't they both have y's? This would be y negative x squared plus 9. Okay, now how do I solve for y? Divide by this negative x squared plus 9. So divide both sides by this negative x squared plus 9. So what I'll get is y is equal to negative 2 over negative x squared plus 9. This has a lot of negative signs in it, so it's also equal to 2. If you change every sign, right, if you multiply by negative 1 over negative 1, this probably is a little bit easier on the eyes. And that's what I get. And does anybody have the answer? Do you know if that's right? That's right, thank you. Okay, so find an equation, so they're saying y equals whatever. It passes through 1, 1. Okay, what does the 1, 1 mean? Right, y is 1 when x is 1. And then they say the slope is this. What's the slope is a fancy way of saying what? Derivative. So dy dx is equal to y squared over x cubed. All right, and my goal is to solve for y. First you, what guys? First you separate, very good. So you take all your y's to the left side, but you have to use real algebra, okay? So what I get a lot of times is this. I'll get this, and you guys tell me what I did wrong. This is what I'll get. I used fake algebra. Do you guys see that? What part did I do wrong though? Because a lot of students don't see what's wrong here. The x cubed can't just flip to the top. Does that make sense? The x cubed stays at the bottom even when I multiply both sides by dx. Do you guys see that? So what I did was basically on this problem, did I cross multiply? No, I didn't even cross multiply. What I did was I multiplied both sides by dx and I divided both sides by y squared. Okay, you guys, good on the algebra here. You guys have to use real algebra, okay? Not the fake stuff. All right, first you separate, then you what? Integrate. So let me integrate both sides. Okay, guys, you focus on one side at a time, okay? So cross out this side. How in the world do I take the derivative? I'm sorry, take the integral of this. You have to rewrite it. You have to move y squared to the top. When I move y squared to the top, what happens to that exponent? Okay, so let's go ahead and take the integral of this. You're going to add 1, divide by negative 1. So that's going to be negative y to the negative 1 plus c, but I'm going to move c to the right. Is everybody good on the left side? Yeah? Okay. So guys, let's move to the right side. Okay, guys, do the right side totally separately from the left side. Don't do them together because you're going to get totally confused. All right. On the right side, how do I integrate when x to the third is on the bottom? Move it to the top. If I move it to the top, what happens to that 3? Okay, so this is actually the integral of x to the negative 3 dx. All right, let's go ahead and integrate. Add 1 divided by negative 2. So that's going to give me x to the negative 2 over negative 2, which will be negative 1 over 2x squared. Are you guys good with that? That's negative 1 over 2x squared. Is that right? Because this is really 1 over negative 2x squared, right? Move that x squared to the bottom. Okay, you guys good so far? Okay. I forgot something. Charlie. Did you guys see how I forgot Charlie? That was terrible. That's like leaving him in the car. Okay, guys? You can't forget Charlie. All right. First you separate, then you integrate. Sometimes you exponentiate. Do I need to exponentiate here? No, why not? There's not an ln y, okay? So what's my next step? Solve for y or solve for c. Which one do you want to do first? Okay, so if I solve for y, let me simplify this. Y to the negative 1 is unsimplified. And the reason it's called unsimplified is because it's really hard to work with unless you're taking derivatives or integral, okay? So move that y to the bottom. Move that y to the bottom, okay? Now I'm going to solve for y. I think the easiest thing to do is, let me go ahead and multiply through by negative 1. If I multiply through by negative 1, this is what I'll get. I know my c is not the same. I know my c should be a negative c, but I'm just going to change this to a positive c. I'll change all my c's because I just like to work with positive c's. Okay, so everything gets multiplied by negative. This c just changes to a new c, okay, which means I need to be working, if I plug in, I need to be working from here down. Don't work with these c's because these are different. Okay, need to solve for y? Any suggestions? Plug in. Well, multiply both sides by, like what can I multiply both sides by? To get rid of this y on the bottom, y. So multiply both sides by y. And what I'll get is 1 is equal to, and you distribute this y. So you get, actually you don't even have to distribute the y because you have to undistribute it. Let's not distribute it. I get 1 over 2x squared plus c, right, y. You agree with that? And now I can solve for y, right? So I can solve for y. So what's y equal to? 1 over 2x squared plus c. That's a little awkward though. How do I get rid of this denominator? Maybe I'll solve for y. Let me distribute the y. I'm trying to get rid of this denominator. Let me distribute the y. So it'd be y over 2x squared plus cy. Okay, guys, when it's c times y, that's not a constant. Y is not a constant. Does that make sense? So you can't change it to a c. Like if it were c times 2, e to the c, those are all constants. The c times y is not a constant. So you can't just change it to another c, FYI. Okay, how do I get rid of this 2x? Oops, this is a 1, sorry. Okay, how do I get rid of this 2x squared? Multiply everything by 2x squared. You guys good with that? Multiply this by 2x squared, multiply this by 2x squared, and so I'll get 2x squared is equal to y plus cy 2x squared. Okay, you just multiply by the denominator, and that helps you conk out the denominator basically. And now I can solve for y. Do you guys see how I can solve for y here? How do you get a y by itself here? Factor it out. So this becomes y times 1 plus 2x squared c. Okay. So this whole thing becomes y is equal to 2x squared over 1 plus 2x squared c, which is a little bit awkward. I would take that as an answer. Let's find out how to solve for Charlie. What is the initial condition? X is 1, y is 1. Okay, so there's my y equals. Okay, when x is equal to 1, y is equal to 1. So this will be 1 is equal to 2 times 1 over 1 plus 2 times Charlie, right? Okay, so I need to solve for Charlie here. So this is 1 over 1. Let me cross multiply because I have one fraction on the left, one fraction on the right, and an equal sign in the middle. If I cross multiply, I'll get 1 plus 2c is equal to 2. 2c then is equal to 1. So c is equal to 1/2. So come up here and c is 1/2. So that gives you y is equal to 2x squared over 1 plus 1/2 times 2 is what, guys? 1, right? So that's where you get the x squared. And is this what you said the answer was?
Yes.
Okay, so there's your answer. All right, so a lot of algebraic manipulation. Could you follow it? And you actually didn't have to do it the way I did it. I mean, there's lots of algebraic ways to do this. It might have been easier, I'm not sure, but it might have been easier to solve for C first, and then plug it, and then solve for Y. Okay, so sometimes one way is easier than the other. All right, what other questions do you have? Okay, guys, we're looking at number 10. Okay, so here's number 10. Okay, dy dx is equal to y cosine x. And you've got your initial condition, and then what's y equal to, which is what we're always trying to find anyway. Okay, first you what, guys? First you separate. And the only thing that you have to move, the only thing that's in the wrong place is this y, and then you multiply both sides by dx. So did you get the same thing I got? First you separate. Then you what? Then you integrate. So let's go ahead and integrate both sides. Okay, guys, do them separately. So what's the integral of dy over y? Isn't that just du over u? What's the integral of dy over y? Isn't it the same as integral of 1 over x dx? What is that? ln of u, or ln of y. So this is ln of y plus Charlie, but move Charlie to the right. What's the integral of cosine x? Sine x. Does it have a negative or not? No. So this will be sine x. Don't forget Charlie. All right. First you separate. Then you integrate. Sometimes you exponentiate. Do I need to exponentiate here? Yes. Okay. So go ahead and e both sides. Guys, make sure this is a positive ln before you e it. If it's not, multiply everything by -1. Okay. So this would be e and e. So what I get is the cap falls out, and you can actually let the absolute value fall out too. So this would be e sine x plus c, but I'm going to change this. If you guys are okay, I'm just going to skip my normal step and just call it c e to the sine x. You guys good with that? Okay, and technically, again, this should be changed to a different c. So I'll change it to be technically right, but I'm not going to have it fit if you don't. All right, there's my answer. Do you want to solve for y, or do you want to solve for c first? Okay, probably C, because y is already solved for. Does that make sense? Okay, what's my x equal to and what's my y equal to? Wait, it's got to have something. Is it? Okay, so x equals 0, y equals 3. So that means everywhere, okay, so this is my answer, but now I'm solving for C. So everywhere there's a y, I'm going to put in 3. Everywhere there's an x, I'm going to put in 0. But do you see that that's just sine 0, which is 0? What's e to the 0, guys? 1. So c is going to be equal to 3. So my answer is going to be y is equal to 3e sine x. Okay, or just really changing this to a 3. Okay. What other questions do you guys have? All right, guys, I'm going to go ahead and check homework. You guys finish up this worksheet. It's due tonight or tomorrow when you guys come into class. Also, I'll check off your, let's see, if you have your contextual problems, I'm missing that from Chris, and then Sophia, the other half from Sophia. Paula, need that from you, the contextual problems. That's 2.5-2. Okay. Colin, Sydney, Paige. Is Andrew here? No. Karina, if you finish that, show that to me. And that's it. And that's it. And then I also need to see your homework from last night. Okay, so Sophia, do you have the, oh, Sophia, you just finished, you had it finished. It's just like a small part. Yeah, did you finish that one? You still working on it? Paper, but I didn't write it okay, just don't worry about it. It's a small part. That's fine. And then do you have your homework from last night? Yes. Okay. Okay, how many pages was it? It's probably just 2. Okay, 1 to 7. Okay. But I finally figured it out. Okay, so let's say minus, and that's just 11, right? So minus 2, and then show me tomorrow if you have it then. Yeah. Colin, do you have your homework on your desk? Okay, just leave it on your desk. Do you have the old homework? Because you were missing contextual problems. 2.5-2. Nice, nice. You finished all of it? Oh, you're still working.
Well, I don't know. Is that all you have to do since we don't know either?
No, you do this. You have to set up the equation based on the proportional thing. That's what we were talking about. This is a K. Inverse and proportional means 1 over T. It says R is equal to K over proportional to the square root. R square root of R is equal to K times 1 over T square, 1 over T. It's just 1 over T. The R is a square root. So see if this makes sense. R is equal to K times 1 over T. Okay, then you, wait. No. Sorry, that's not right at all. dr dt is equal to K times 1 over square root of R. dr dt is equal to K, right? Times what? What's inverse?
Square root of R.
Yeah, times 1 over square root of R. Then you separate. First you separate, then you integrate. Okay. All right, Chris. Nice. Okay, so 1, 2, 3. Okay. And then what about the 2.5-2? Okay, so how much do you have then?
3 and 4.
Sorry. Okay, so just 2 of them then. Okay. Nathan, do you have worksheet from yesterday, 1 through 11?
I don't have those.
Okay, nice. And nice.
I have
9, 10, 11. Okay. Actually, you guys are going to turn this all in one shot, right? I'll just check it tomorrow. Yeah, the contextual ones. Yes. So Karina. Oh, Karina, you had almost all of it done. It was just like a small part you didn't have done. Sorry. The contextual one, Paula. No, you had it done. It was just like all but a small thing. That's all. So it wasn't a big deal. Yeah. Sorry about that, guys. I'll check your homework tomorrow because that's what I said. I'll do all of it at one time. So let's just do one homework grade on this one. Number 11. Is that tonight's homework, or is that? Oh, is the last one, right? Okay. Okay, guys, let's look at number 11. Guys, you guys should be doing this on your own. So it's lovely, guys, that I'm doing all the problems for you, okay, or with you. But I need you guys to take it home and do it on your own, because it's different when you work it out by yourself than when you're working it with the key, all right? It's a lot different, all right? You should be working it by yourself and then making sure that you can do it. All right, guys, you have to change it to this problem. Did you change it to this problem? I think we talked about that yesterday, okay? So first you separate, then you integrate. The 2 is in the right place, guys. It's just the y that's in the wrong place, and the dx is in the wrong place. So what I'm going to do is divide both sides by y. So I'll get dy over y dx is equal to 2. And I'm going to multiply both sides by dx. So I have dy over y is equal to 2 dx, all right? So you need to move all the y's to the left side, all the x's to the right side. First you separate, then you what? Then you integrate. What is the integral of dy over y? ln of y. So this is the ln of y plus Charlie, but I'm going to move Charlie to the right side. Okay, what is the integral of 2 dx? 2x, beautiful. Okay, but now you have to remember Charlie. Okay, first you separate, then you integrate. Sometimes you exponentiate. Do I need to exponentiate in this problem? Yes. Okay, so I'm going to put a big old E. Okay, and what happens when you tree a log? The cat falls down. Do you see the y falls down? Okay, this is going to be e to the 2x plus c. And again, guys, I'm going to take a chance on this, but I hope that you just understand that you can just write this as c e to the 2x. And why you do that is because of the e to the c. Okay, and these are really different c's, although you don't have to write that. Okay, so this is actually my answer. Y is equal to c e 2x. But do I have an initial condition I need to take care of? What is it? When x is 2, y is 1, right? Okay, let me see if I memorize that when I come down here. X is 2, y is 1. All right, so what I'm going to do is everywhere there's a y, I'm going to put in 1. Everywhere there's an x, I'm going to put in what? 2. Okay, so I get y times c e to the 4. Okay, solve for c though. Isn't c equal to 1 over e to the 4? Right? Okay, then just plug it in. C is equal to 1 over e to the 4. Okay, well, if that's true, what's y going to be equal to? Isn't that 1 over e to the 4 times e to the 2x over 1? So what is that? E to the 2x over e to the 4. Okay, and that's a great answer. But another answer some people might see is that y is equal to e to the 2x. What do you do with the exponents when the bases are the same and you're dividing? You subtract them. If you're multiplying, you'd add them. If you're dividing, you subtract them, as long as you have both bases are the same. Okay, so first you separate, then you integrate. Okay, the separation means all the y's go to the left, so you got to use real algebra. So did you get this when you separated? First you separated, right? Then you integrate. So now I'm going to integrate. Okay, how do you integrate? Let's just focus on the left side. So don't focus on the right side right now. Don't focus on the right. Okay, how do you integrate when I have y squared on the bottom? What'd you say? Oh, that's only if you have only y. Oh, actually, I could try that. Watch. Actually, that's a good, no, you're right. Let's just try it like, let's try it as the u. Okay, so it'd be like that, right? Okay, if I make this my u, what's the derivative of y squared? 2y. Do all my y's cancel out? No, so that's, you can't do that. Got it? But you want to check it. That's a good thing. You want to check it. And if they don't all cancel out, then it's not an ln problem, is what you're saying, because it's not an ln problem. Okay, how else can you do this? Bring it up. Okay, well, what happens if I bring it up though? Yeah, it becomes negative 2. All right, I'm only working the left side first, guys. Okay, so this becomes y to negative 2. That's an easy antiderivative, right? So I'm going to add 1, divide by the new exponent, which is negative 1. So I get y to the negative 1 over negative 1 plus Charlie. But isn't this really negative 1 over y plus Charlie? Are we done with the left side? Okay, let's go to the right side. So this is equal to, let's go to the right side here. What is the integral of negative x? What is the integral of negative x? Negative x squared over 2. Don't forget him, Charlie. All right, so this is equal to negative x squared over 2 plus Charlie, but I only need 1 Charlie. You guys good with that? Okay, so I'm done with the integration. First you separate, then you integrate. What do you do next? Solve for y or solve for c. Okay, what do you want to solve for first? You guys tell me. Okay, let's solve for c. What's my initial condition? Can someone tell me? Y equals 1. X equals 1. Okay. So I'm going to change the y to negative 1/4. I can see that fractions are going to be involved here. Negative 1/4. Okay. So y is going to be negative 1/4. X is going to be 1. So do you guys see that this is just 1 squared, right? So that's 1. This is going to be negative times negative is positive. 1 divided by 1/4 is 4. Okay. Is equal to, this will give me negative 1/2 plus Charlie. So do you see Charlie is 4.5 or 9/2? I'm not sure which one's going to be more useful. Is good with that? It depends on how you did Charlie. It depends on how you did Charlie. It depends on what equation you started with when you had Charlie. Well, someone said solve for C first. Hey guys, you gotta help me out here. Okay, you want to solve for Y first? Okay. If you solve for y first, what do you all want to do? You want to solve for y first? We can do it. Okay, no, just tell me what to do. Because everyone does it differently is all I'm saying.
What was wrong with the way you did it?
Well, the left side of the room objected. It doesn't matter. It doesn't matter. It works both ways.
I just heard something different answer for C, so I wanted to see if it was different.
Oh, yeah, you're fine. No, you're fine. So what did you do here? No, you get the exact same answer, but the steps come into it will be different. Okay, so do you want to multiply by -1? I don't know how you did it, is what I'm saying. Oh, okay, so you're just telling me to do whatever I want. Okay, you're telling me to do whatever I want is what you're saying. Okay, so guys, stop me and tell me to change if you did it a different way. I'm going to multiply through by -1. You guys good with that? So that'll be 1 over y is equal to x squared over 2 minus c. You guys good with that? Okay. Then what I'm going to do is, do you see that this is a negative c? It doesn't matter if it's positive. Do you agree? Because negative c is some constant, just like c is. So this will be c1. Okay. All right. Or that's not c1, but that's c1 right there. Okay. So this I'm going to solve for y. So what I'm going to do is I'm going to multiply through all by y. So this will be, I'm going to multiply by y on this side, and I'm going to multiply by y on this side. So that's going to be 1 is equal to x squared y over 2 plus cy. Is good with that? Well, I already multiplied all through by -1. Okay, and then that's why I got the positive c. It should be negative c also, I think, but then I just said negative c is c. Okay, so then what I did is I multiplied through by y because I'm trying to get rid of the y on the denominator, and this is what I get. And then what you want to do is I want to get rid of this 2 in the denominator. So what do I do to multiply? What do I multiply to get rid of the 2 in the denominator? Multiply everything by 2. Okay, you guys good there? And then y, if I solve for y, what I would do, you could change this constant to another constant here, but there's a lot of things going on here. So what I'm going to do is I'm just going to factor out the y. You guys good? I'm just going to factor out the y. Okay. And then I'm going to solve for y. So y is equal to, divide both sides by this thing right here, x squared plus 2c. So y is equal to 2 over x squared plus 2c. Okay. And the c isn't always going to be the same because it really depends on what method you use. What's going to happen is your answer will always be the same. Okay. But your c will be different depending on if you call this c another c or not, right? So do you guys want to call it another c or do you want to leave it? Okay, we'll leave it. So what did I know about x and y? Can you tell me again? X is 1 when y is, okay, so that's -1/4, right? So what I know is I've solved for y, and now I need to solve for c. So it's -1/4 is equal to 2 over 1 plus 2c. Okay, did I do that right? The y is -1/4, the x is 1, okay? So then I need to solve for 2c. Okay, actually, this is my answer. Is everybody good with that? This is my answer. I just need to solve for c. Okay, so I'm going to cross multiply. If I cross multiply here, I get -1 minus 2c is equal to 8, if that's a 4. Okay, then I get 9 is equal to 2c. I don't know why I'm going so slowly here because I'm thinking c is 9 over 2. That's what I'm getting here. C is 9 over 2. So if c is, did I lose a negative? Oh, wait. 2c is equal to, is this -9? Okay, let's start over. -2c is equal to 9, right? So c is equal to -9 over 2. Okay, so this c right here, guys, will be -9 over 2. So if you multiply 2 by -9 over 2, what do you get? Yeah, -9, right? So this is going to be y is equal to 2 over x squared minus 9. Did anybody get that in their final answer? Okay, so that's the answer. Okay. Oh, it's not wrong. They just didn't want to do it that way. You want. Oh, but the c doesn't necessarily have to be the same. It's just your answer will end up the same no matter how you do it. Okay, so do you want me to do it your way, Sadie? Okay. No, I can. If you want, I can do it your way. Okay, you're good. No, there's only. Oh, no, your c can be an infinite number. I mean, I wouldn't say. No, you can't get c wrong. But when you plug, it depends on when you solve for y, what you got. Does that make sense?
So you're never gonna ask I go to C?
No, not in these problems. Yeah. Well, you have to solve for C. You have to plug it in. It's just that your setup might be different. So depending on what your setup was for Y, it'll always, the answer will always end up the same. Okay. All right. Let's do another one. What other problems do you want help with? Number 9. What number was this one? Number 5. Okay. So 6, 7, 8, 9. Oops, that's 8. Okay. You guys ready? Here's number 9. All right. So first you separate, then you integrate. Okay. Before today, when we had differential equations, I never had a y on the right side. And so now we have x's and y's, or maybe just y's. Okay, so first you separate. Guys, when you separate this, I know that you have this urge to move the 3 over, but it'll make things harder. I'm just letting you know if you move the 3 over. Okay, so it's a lot easier if you only move the y's and x's. Okay, if you move numbers over, it makes things harder. Okay, so first you separate, then you integrate. Okay, what's the integral of dy over y? Well, think about it. ln, right? Because if I make the whole bottom my u, okay, the derivative of y is 1, right? If I divide this by 1, do all my x's cancel out? Yes. So this will be 1 times the ln of the entire bottom. So that just becomes ln of y plus Charlie, but I'm going to move Charlie to the right side. What's the integral of negative 3 dt? Negative 3t, but don't forget him, plus Charlie, okay? All right, this right here is going to be just ln of y. All right, first you separate, then you integrate. Sometimes you exponentiate. Do I need to exponentiate here? Yes, so I'm going to big E on both sides. The cat falls out because I'm logging a tree, or I'm treeing a log. And then over here, this becomes e to the negative 3t plus c, and the c is in the numerator, okay? Guys, whenever you see this, you can always just change it to ce to the negative 3t. Are you guys good with that? Okay, if you want to know why, it's because this is this thing right here. I mean, if you really want to know why, okay? But really, you can just, when you have c in the numerator with an e, you can just move this c, which is actually a different c, to the front, okay? All right, and technically, these are different c's now. Okay, so I'm pretty much finished. I've got y equals, okay, first you separate, then you integrate, sometimes you exponentiate, and now I solve for y and c. I've already solved for y. Okay, let me solve for c. Can someone tell me what my initial condition is? X equals what? T equals 0 and y equals 1. Okay, so t is like my x here. Okay, so y is going to be 1. T is going to be 0, so that's a 0 exponent. So what's your c equal to? 1. Okay, so all you do is you put 1 in here, which really just makes it disappear, right? And there's your answer. Okay. Oh, okay, so the question is, what is t when what? Okay, so do the same thing, guys. Put in y is 1/3 equals e to the negative 3t. Guys, how am I going to bring that t down to the ground? Multiply by what? How do you undo an e? ln it, yeah. So ln both sides. I'm going to ln this side, ln this side. When you log a tree, guess what happens? The cat falls out, but you still have an ln on this side. So it'll be ln of 1/3 is equal to negative 3t, okay? And so to solve for t, you just divide by negative 3 on both sides. T equals ln of 1/3 over negative 3. And that is my answer. You could put that in the calculator if you want, but this is an exact answer. No reason to round it. Okay, this is a great answer. So this would be dy over, okay. Do you see that this has a y in it right here? And I know the L is there, but it's just a constant. Just think of it like 30 or something, okay? You would still divide both sides by L minus 1. So I'm going to divide both sides by L minus 1. I'm going to multiply both sides by dx so that I can get the dx on the right. So what I get is dy over L minus y is equal to k times x dx. Did you guys get that? Okay, first you separate, then you integrate. So let me go ahead and integrate this, okay? How do you integrate this on the right, left side? Ignore the right side. Don't do both at one time. Let's just do the left side. What's the integral of 1 over L minus y? Okay, make this my u. Just pretend like this is 30 minus y over, say, 1. If I made the whole bottom my u, what's the derivative of L minus y? What's the derivative of 30 minus y? Negative 1. Okay, so then the shortcut is you divide the top by negative 1. Do all my y's cancel out? Yes, so this is negative 1, because that's what I have left, times what, guys? ln of this entire bottom, which is L minus y. And that's the shortcut. It only works if you make your u the entire bottom, if you took the derivative of the entire bottom and divided it on the top, and all the y's cancel out. That's the only time you can use this shortcut. All right, so I'm pretty much done with this. Are you guys okay if I take this negative 1 and just change it to negative? You guys okay if I just do that? Okay, and this is a plus c, but I'm gonna move all the c's to the right side. Let's look at this right here, the integral of kx dx. Remember, k is just a constant, just like L. So if I had the integral of 3x dx, what would it be? 3x squared over 2, right? So what would be the integral of kx dx? Kx squared over 2. Do you see how easy that is? All right, and then don't forget Charlie. All right, so we're good to go. First you separate, then you integrate. Sometimes you exponentiate. Do I need to exponentiate here? Yes. Can you tree a negative log? No. What do you have to do? Multiply everything by negative 1. So there will be ln. Guys, you don't multiply this L minus y by negative 1. The negative is just on the outside of this whole term. All right, so that would be positive ln of L minus y is equal to negative kx squared over 2. And now I'm going to keep this a positive Charlie. I know it should be negative Charlie, but I like positive better, so that means I'm going to change this Charlie to a 1. These are different Charlies, and I'm going to be working with this Charlie down here, okay, not this Charlie up here, okay, when I plug in my C, if I have to plug in my C. Okay, first you separate, then you integrate. Sometimes you exponentiate. Are you ready to exponentiate? Let's do it. Okay, so I'm doing a big E on both sides. What happens when you tree a log? The cat falls out, so let him fall out. All right, on this side, I'm gonna do a little shortcut if you're okay with this. This is really CE to negative kx squared over 2. You guys okay with that? But remember, this C is different from this C, so I'm gonna call that a C2. They're different C's, because this is really E to the C on this one. This is really E to the E to the C, which is still a constant. Everybody with me so far? Do you want me to show you how I got this big C? No, okay. So first you separate, then you integrate. Sometimes you exponentiate, and now you do what? Solve for what? Y and C. So let's do it. What do you want to solve for first? Y, okay. If I solve for Y, I want to get Y on one side. So this will be L minus CE to negative kx squared over 2 is equal to Y, right? I've solved for Y. All right, let's solve for C. Can someone tell me my initial condition? Oh, there is none? Oh, when we're done. Did that help, Cynthia?